Hello, algebra students. Today we're covering section 7.3. Please put your name and date on your guided notes. Our topic is simplifying complex rational expressions. By the end of this section, you will be able to simplify a complex rational expression by writing it as division, and simplify a complex rational expression by using the least common denominator. And here's a few examples of complex rational expressions. You can see that there's a fraction in the numerator and fractions in the denominator. So there's two ways that we can do this. We can simplify the numerator and denominator separately and then divide, or we can multiply the numerator and denominator by the LCD of all of the fractions appearing in the numerator and denominator. So let's try both methods. Let's start with just simplifying the numerator and denominator separately. So in part A, we can multiply this 6 by 2 and the 1 by 2 so that we get 12 in the denominator. So we would have 7 minus 2. And then since the denominator is the same, we can just write it over 12. Then in the denominator, we have a denominator of 9, so we would have to write this over 1 and then multiply by 9. 2 times 9 is 18, and we're adding, and the denominator is 9. Then we have to divide. So when we divide fractions, we keep change flip. Actually, I'm going to go ahead and do that subtraction first. 7 minus 2 is 5, so we have 5/12 times 18 plus 4 is 22. 22 over 9, so I'm going to flip it to 9 over 22. Okay, so this one we flipped it. Now before I multiply, I'm going to cross cancel because 9 can be divisible by 3 and 12 is divisible by 3. Then we multiply. 5 times 3 is 15. 4 times 22 is 88. All right, so that's method 1, where we simplified the numerator and denominator separately and then divided. Now we're going to do method 2, where we're going to multiply by the LCD. So for 6, 9, and 12, those are our denominators. We can have factor trees. And then we look at the least common, and we have to take the one with the highest exponent. So we have 3 squared, and we have 2 squared. 2 squared is 4, 3 squared is 9, 9 times 4 is 36, so the LCD is 36. All right, so I'm going to multiply everything times 36. Let's just rewrite the problem. 7/12 minus 1/6 over 2 plus 4/9. I'm going to multiply by 36. Everything gets multiplied by 36. When we do that, if we multiply 36 times 7/12, the 12 and the 36 cancel. 12 goes into 36 3 times. So 3 times 7 is 21. Then I can cross cancel the 36 and the 6 and the 1/6. 6 goes into 36 6 times. 6 times 1 is 6. Okay, so that's what these fractions multiplied by 36 become. 21 minus 6 divided by 36 times 2 is 72. 36 times 4/9. I'm going to cancel the 36 and the 9. 9 goes into 36 4 times. 4 times 4 is 16. Now I'm just going to simplify this. 21 minus 6 is 15. 72 plus 16 is 88, and you can see that both of these are equal, 15/88ths, using both methods. Let's practice those two methods again. We need a common denominator to subtract z minus 1 over z. So the common denominator will be z. I'm going to multiply by z over z. Put this z over a 1. Z times z is z squared. Z times 1 is z. Minus 1 over z. Over, same concept, we have a z in the denominator, so we're going to multiply the 1 by z over z. Put a 1 in the denominator. That becomes z over z minus 1 over z. Now we can simplify. So that just becomes z squared minus 1 over z. And I have z minus 1 over z. I probably could have skipped straight to that step. Now I'm going to multiply by the reciprocal. So z squared minus 1 over z stays the same. Change it to multiply. Flip the denominator. So z is in the numerator and z minus 1 is in the denominator. These z's cancel, and if you notice, this is a difference of squares, so that's going to factor to become z minus 1 and z plus 1. And in the denominator, we have z minus 1, so we can cancel again. We can cancel the z minus 1s because we can put that in parentheses, leaving us with just z plus 1. Let's try the other method of multiplying by the least common denominator. So the least common denominator is z. I'm just going to rewrite the problem. Z minus 1 over z over 1 minus 1 over z. I'm going to multiply everything by the LCD, which is z. So this becomes z squared. This, the z's cancel, so you're just left with minus 1 over z. The z's cancel, so you're left with just minus 1. This factors to z minus 1, z plus 1 over z minus 1. And we end up with the same thing with a lot less steps, z plus 1. Okay, when you're ready, turn your page. In this example, we have to rewrite this problem without negative exponents. So I'm going to write this as 1 over a minus 1 over x over 1 over a squared minus 1 over x squared. Now in the numerator, I need to multiply, for the first method, the first fraction I'm going to multiply by x over x. And the second fraction I'll multiply by a over a. All right, that gives us 1 over ax minus a over ax. Or we could just write that as x minus a over ax if you wanted to skip to that step. All over, and this one I'm going to multiply by an x squared over x squared and an a squared over a squared. That's going to give us x squared minus a squared over a squared x squared over a squared x squared, or you could skip that step and just write x squared minus a squared over a squared x squared. Give you a second to catch up to that. Okay, now we're going to rewrite it as multiplying by the reciprocal. So I'm going to flip this one on the bottom. So keep the numerator times the reciprocal a squared x squared over x squared minus a squared. That's a difference of squares. So now I'm going to bring that down here so we can keep simplifying. The x minus a I'm going to leave alone. But the ax, I'm going to cancel that with these, and that becomes just ax in the numerator. So times ax. And in the denominator, I'm going to, so this has to be in parentheses because we're multiplying all of that. X minus a and x plus a, because that's a difference of squares. Then we can cancel. These cancel, leaving us with just ax over x plus a. It's a little abstract because it's all letters. But let's try it the other way, where we multiply by the LCD. And let's see if it's a little bit easier, maybe less steps. I'm going to rewrite the problem, but I'm going to write it without negative exponents. Then my LCD is going to be a squared x squared. Okay, so in the numerator, if I multiply this first ratio, rational expression, I get an a canceling. So 1 times that would be ax squared. Right, because we're multiplying that by over 1. So the a in the denominator canceled, minus, if I multiply this one, the x in the denominator cancels, sorry about that. The x in the denominator cancels, leaving us with just an a squared x in the numerator. Over, in the denominator, the a squareds cancel, leaving us with just x squared. And then this one minus the x squareds cancel, leaving us with just a squared. Now to simplify this, I have to factor some things out. So in the numerator, I'm going to factor out an ax, leaving us with x minus a. And in the denominator, that's a difference of squares. So I have x minus a and x plus a. We have something that can cancel. So our final answer is ax over x plus a, which is exactly what we got when we did the first method above. Let's try problem D. Okay. I am noticing that this 2 minus x, if we factor out a negative, we could get something that looks like the rest of the problem. So I'm just going to rewrite this problem as 1 over x minus 2 minus 2x plus 2. But in the denominator, I'm going to make that 3 a negative, and that way I can make the denominator x minus 2. Because it's an opposite. Then, in the first rational expression, 1 over x minus 2, I'm going to multiply that by x plus 2. So 1 times x plus 2 is x plus 2. Then our denominator will be an x minus 2, x plus 2. Great, because I'm multiplying this by x plus 2. Then I'm going to multiply this one by x minus 2 so that we have a common denominator of the x minus 2, x plus 2. So 2 times x is 2x, and 2 times negative 2 is negative 4. All right, and in the denominator, I'm going to multiply this one by x plus 2. So negative 3 times x is negative 3x, and negative 3 times 2 is negative 6 over x minus 2, x plus 2. Then I'm going to multiply the 4 times x minus 2 and multiply the denominator by x minus 2. 4 times x is 4x, and 4 times negative 2 is negative 8. All right. Now we're going to rewrite this as keep, change, flip. First I'm going to collect like terms. Let's do that first. 2x plus x is 3x. 2 minus 4 is negative 2. I think I made a mistake. Hold on. I forgot that there's a minus right here. And so I made a sign error. This should actually be a minus 2x. And then this would be a plus 4. Okay. Sorry about that. So x minus x is actually, or x minus 2x is going to be negative x, and 2 plus 4 is 6. And if you're not okay with a negative x, that's fine. You can write it as 6 minus x. Okay, over that same denominator, x minus 2 over x plus 2. And then it's all over, collecting like terms. 4x minus x is x, and negative 6 and negative 8 is negative 14, all over that same denominator, x minus 2, x plus 2. Now I'm going to rewrite it as keep, change, flip. So again, if you would prefer it to be 6 minus x, that's fine, over x minus 2, x plus 2, times the flip of this. So x minus 14 is in the denominator, x minus 2, x plus 2. All right, these are going to cancel completely, leaving us with 6 minus x over x minus 14. And let's see if we can get that same answer using our other method, where we just multiply by the LCD. Rewrite the problem. And then the LCD for this, before I do that, I'm actually going to erase this one. And I'm going to make the 3 negative so that we can write the opposite, x minus 2. It's just going to make less work for us because then the LCD can just be x minus 2, x plus 2. Okay, so multiply the whole thing by x minus 2, x plus 2. And you're going to see things start to cancel. So for the first one, the denominator x minus 2 cancels, and 1 times that is x plus 2. I'll just put it in parentheses, minus, if I multiply this one, the x plus 2 cancels, so we're going to have 2x. 2 times negative 2 is negative 4. All over. Multiply this one. The denominators cancel, the x minus 2, x minus 2. Then it's going to be negative 3 times x, which is negative 3x. And negative 3 times 2 is negative 6. Plus, multiply these ones. So the x plus 2's cancel. 4 times x is 4x. And 4 times negative 2 is negative 8. All right. Now we're going to collect like terms, because that minus. So x minus 2x is negative x. 2 minus negative 4 is positive 6. Over. Negative 3 plus 4 is, or negative 3x plus 4x is x. Negative 6 plus negative 8 is negative 14. And again, you could write this as 6 minus x if you prefer. But we get the same answer. All right, that was a lot because I did both methods. When you're doing your work, you can choose which method you prefer. Go ahead and think about something you learned today, write that in your summary, and then we'll have time to start our homework.